Welcome back to the practical instruction. We ended last with the main organs of the plant. However, I forgot to show you the drawings I made of the root system. That also needs to go into your research journal. So next up is the detailed morphology of the flowers.
I've put the flower, the inflorescence of the cocksfoot under the microscope, and you can clearly see the different parts of the flower. You can see the stigma and you can see the anthers. What you should see are the anthers and the stigma, which isn't visible on this model. These are the young anthers. These are the anthers when the inflorescence is finished. So come and have a look. So here you can see the stigmas and the anthers which have come out of the flower in the inflorescence. So you can find all the parts of this flower in your plant biology book. So I want you to identify all of those when you draw it. Sunflower is a composite flower. It actually contains several flowers. You can destroy it like that. And then you clearly see two types of flowers. There's the disc flower. The disc flowers are completely hollow. And the ray flower has these fused petals. Here the petals are also fused to form a tube. And at a microscope, obviously this is quite a big flower. And under the microscope you can see here the stigma, which is curled up, and inside I expect there to be anthers. We'll try and pry it open in a minute. And here you can also see the ovary, which will contain one ovule in this case. Here you can see how I've pried open the disc flower and I have made the anthers visible, these brownish things. If we put the ray flower under the microscope, let's get the focus right, we don't see a stigma. In fact, I don't think there's anything there at all. So this flower is sterile. It contains no sex organs. So the sunflower is a composite flower similar to, for example, chamomile, and here you can clearly see enlarged the ray flower, the disc flower, which also has been opened up to show the stigma and the ring of anthers which surrounds the stigma. Here you see a tiny little stigma, so in this case that would still be able to receive pollen, but it does not contain any anthers. So once you've had a good look at your flower and all the organs, it's time to take the pencil and draw exactly what you see. You can make it much larger than what you see if it's a tiny flower, obviously, because you want to make sure that all the detail is clearly visible. Don't forget to add the scale. If you've made something twice as big, it's a 1:2 scale or a 1:5 scale, which means 1 millimeter is 5 millimeters or 1 centimeter is 5 centimeters. If you have a legume, this also has a very typical flower, which is bilateral symmetrical. It has a keel, and when you open it up, I'll show you in a minute under the microscope. You expose the stigma and the anthers. Also, if you have fruits on your plant, we will describe those as well. So here you have a model of a leguminous flower. Like I showed you, I opened up the keel to reveal the anthers and the stigma, which is also visible from your pea flower. So when you draw it, make sure you draw all the organs and also name all the organs. We'll show you in a minute. So back to the research journal, back to the drawing board and make the drawings.
Similarly, if you've chosen, for example, a plant from the solanaceous family, you may have fruits on it. This is a pepper plant. I was hoping it would have flowers. You can see the flower buds, but they haven't opened yet. But I have the flower of a tomato plant, which have similar structure and form, where you can also clearly see the sepals, the petals, the anthers, and the stigma is inside the ring of anthers. We'll have a look under the microscope. So here I've put the tomato flower under the microscope, and you can see that the anthers have fused to form a tube, and inside the stigma is present.
So back to the research journal, back to the drawing board and make the drawings. Here you can see the tomato flower, clearly indicate where the petals, sepals are, where the pistil is, where the anthers are. You can also indicate the stigma of the pistil, the peduncle of the flower, and don't forget your figure numbers and good labels. Similarly, here I've drawn the pepper fruit. You can make a section through the pepper fruit to also show the inside where you can see the seeds, and also show the peduncle again, and a good label, of course, which you can use to refer to your figure in the text.
So depending on the crop you've chosen, you will do something similar to what is depicted here. We'll show all the morphological properties of your crop, the inflorescence, the leaves, the shape of the leaves, the way it's positioned, and if you have, for example, another important morphological characteristic like the tubers. This is a floral formula, we're not going to do that. I have a similar one for pea.
Yeah.
So pea, again, you have the flower of the legumes, you have the shape of the plant, the growth habit, the fruit, and the flower with the organs.
So that was the end of the instruction practical, or the practical instruction rather. So now you know what to do. Get started, find yourself a crop that you like and dissect it morphologically. Make sure you have all the correct drawings. Use your magnification glass to look at the specific detail of every organ, and also if you have very small flowers, use that to enlarge it so that you can make a good drawing of what you see. If you have any other questions, don't hesitate to mail me or ask me during the Teams meetings or during the actual classes. Thank you. Bye.